Good morning and welcome to Going to Work with Gena, which is an inspiration for STEM students. I am Dr. Gena Henderson and it is Python Wednesday, yes. And you know, we always tell you what we're diffusing on Python Wednesday. And this morning we are diffusing grapefruit, basil, and lemon. And this combination is a vitality combination that you can actually ingest, okay? And so this morning I'm taking it all in as we get ready to get into our lesson this morning. Now, remember what I told you from last week? We kind of did like a pre-calculus thing last week. So this week, we're actually getting into calculus. So we're going to review Cal 1. And then what's important for Cal 1? And so what's important for Cal 1 are derivatives, limits, derivatives, inverse functions, and that theorem of calculus, okay? So now when you think of a limit, what you're thinking of here is that basically as f of x is going to be equal to L as x approaches A, okay? So that's like when you're looking at a function and as that function approaches whatever the value of L is, that's the same as saying as x approaches A. Now, when we start looking at the derivatives, this time we're not looking at, remember we was doing things with equation of a line, but derivatives is that tangent line of a curve. And it's at that point where there's velocity also associated with it. And so what you want to do is, it's kind of like looking at M, which is kind of like a slope. And so what you're going to look at the limit as x approaches A of f of x, the function f of x, minus the function of f of A over x minus A. Okay, now, I always try to give an example of this. Remember the parabola that we had last week that goes through 0, 0 going up? Okay, you can also plot this point and use this limit here to try to understand. And so when it comes to these limits, you also want to go right down and understand time being associated to it as an inverse function. And so when you come to an equation, and then you want to make sure that for every point that hits that function for time, if you're looking at a number of things over a period of time, you want to make sure that there's only one-to-one function, meaning that if you were to draw horizontal lines, that line is only going to touch that function once. Okay? All right. So now we get into the theorem of calculus. The theorem of calculus. And I know we're doing all this in a few minutes, but this is review because these are some of the things that we're going to need for Cal 2. Because remember, what we're doing is really Cal 2. All right. So when you think about the theorem of calculus, what that is that it's that continuous function, and it's all of the area that's underneath that function that is bound by maybe an integral. All right, so what you want to think about is when you basically differentiate the integral of the original of a function, it's going to be the original function. Okay, and so when you start integrating over a function and you using from A to B, that's the same thing as saying the function of B minus the function of A. Okay, all right, so those are just some of the highlights of Calculus 1 that you would need in order to begin working in Calculus 2. Okay? Remember, Calculus 2 is our goal. So I want to thank you for going to work with Gena this morning. If there's any infomercials that you've missed, please don't hesitate to go to YouTube, Going to Work with Gena. It is Python Wednesday, yes.